Hello, Algebra 2 students of mine. Just a quick video. I wanted to give you some quick homework hints on 3.1 assignment, and also I just wanted to test out the Remind 101 texting to see if that's working all right. So I just picked out 4 problems that I thought you might need some help on, starting with number 5. So let's take a look at that one. All right, we're multiplying together 2 binomials. So we can either use FOIL or box method or whatever you want to call it, but it's the same thing no matter how you write it. It's just using the distributive property as many times as you need to get everything multiplied together. So we're going to start with this x term, and we're going to distribute it by multiplying it by the two terms in the other binomial. So starting with x times 2x, that's going to give us 2x squared. All right, and then I'm going to also take x times -7. Positive times a negative would give me -7x. All right, now I'm done with this x. I have distributed it. I have multiplied it by both terms in the other binomial. So now let's move on to -5. So let's take -5. Notice the sign in front of 5. It's part of the term. So we're multiplying a -5 times a positive 2x. That would be -10x. And then this -5 times, look at the sign in front of 7, -5 times -7 would give me a positive 35. All right, at this point we're going to go back and collect any like terms. I see 2x terms here that can be combined. So our final answer will be 2x squared, and then -7x minus 10 more would give us -17x, and then plus the constant term of 35. All right, so there's your number 5. Let's move on and take a look at number 9. Okay, now notice that number 9, we're multiplying together 2 binomials that are exactly alike, except that one is a difference and one is a sum. So whenever we have either a situation like this, a times b times a plus b times a minus b, or we could turn that around and say a minus b times a plus b. That's what this problem looks like. 2 binomials, one's a difference, one's a sum. The result is always going to be the first term squared minus the last term squared. In this case, our first term 2x, that's our a, and the 5 is b. So our final answer, we're just going to take that first term and square it. Now remember, I'm squaring 2x. So over here in the margin, I'm just going to write down what we're doing. We're taking 2x and we're squaring that. That means 2x times 2x. So that would give us 4x squared. And then minus, let's square the second term. When you square 5, you get 25. All right, so there's number 9. Let's move on over to, I guess number 20 was the next one I wanted to do with you. All right, notice that this is a binomial that's being squared. This is the same thing as a minus b squared, okay, because I'm taking 2x minus 3 and multiplying it by itself. So we could do it the long way. We could distribute the 2x and then distribute the -3y, or we can use our shortcut property that tells us that anytime I square a binomial that's a difference, the pattern is always the same. The result is going to be a trinomial. The first term will be a squared, the middle term will be -2ab, and the last term will be a positive b squared. All right, so let's use that pattern to multiply here. This 2x, that'll be our a, and then the -3y, that is b. So the first term we're going to take is going to be a squared. Oh, we just did that a minute ago. We just squared 2x. Remember, that means 2x times 2x. So that would be 4x squared. All right. Now our middle term is going to be negative, so it's going to be minus. Now we're going to multiply these 2 terms together and then double that result. 2x times 3y is -6y. When you double -6xy, when we double -6xy, we're going to get -12xy. And then we square the last term. It's always going to be positive, so I'm going to write plus. When I take 3y and square it, let me just write that down here. When I take 3y and square that, that means 3y times 3y, which would give me 9y squared. All right, and then I just wanted to show you one example down at the bottom, filling in the blanks on this chart. So let's just go ahead and skip to the end. Let's look at number 28. All right, in this column, you're going to tell how many terms are in each polynomial. Terms are separated by addition and subtraction signs. So you can see in this problem, we have 1, 2, 3, 4 total terms. So the number of terms is 4, okay? The leading coefficient, remember, is the coefficient of the term with the highest power. So look at all these exponents. Looks like this is our highest exponent. So the leading coefficient will be the coefficient of that term. The coefficient is the term out front. So our leading coefficient is 5. And then the degree of the polynomial will be the highest degree of each of these terms. The degree of this term is 1. There's an invisible 1 here. Remember in class we said the degree of any constant term is 0. The degree of this term is 3, and the degree of the last term is 2. We're looking at these powers to figure out the degree. Since the highest, this is the term with the highest degree, that makes it the degree of the whole polynomial, so the degree is 3. All right, so there's a few homework hints. If you have any other questions, be sure and ask me when you see me tomorrow in class.